Okay, so today's lesson is about is something called the standard deviation of the residuals. Yesterday, we were talking about how to make a residual plot and to take a look at that to see whether or not a linear model was appropriate. So now we have this new measure that we can take a look at mathematically that's called the standard deviation of the residuals. This is not the same as standard deviation that we learned in chapter 1. So you can see with the formula that's here, the standard deviation of the residuals really is summing up for us right here the differences between your actual y values and your predicted y values, which is what we said the formula was for residuals a few days ago. And it's summing all of those up and taking an average of them, dividing by n minus 2. The textbook doesn't really talk about why it's n minus 2 instead of n or n minus 1. And again, you don't have to memorize this formula. It's there for you on the formula sheet. And what this number does is this lowercase s. It tells you the approximate size of a typical prediction error based on your least squares regression line that you've come up with, which is what is here for y hat. The units for lowercase s are the same as whatever data you're studying. So if you're predicting miles per hour, then little s would be in miles per hour. If you're predicting weights, little s would be in terms of weight. So here, just as a reminder, back in chapter 1, we talked about standard deviation. We had mean and standard deviation of a curve or a set of data. And that standard deviation, which is denoted as S of x or S of x bar sometimes, is the typical distance of your actual x values from the mean of your x values. So that's just called standard deviation. It's standard deviation of the values from the mean, but we don't normally say that. We just talk about standard deviation. So in this chapter, we now have this new thing called standard deviation of the residuals, which is just given by a lowercase s. It does not have any type of subscript along with it. And it really is talking to us about the typical distance of your actual y values from the y values that are predicted by your line. This sentence that I have down here, down at the bottom, is again one of your sentences for chapter 3 that you have to be comfortable with. That when you're asked to describe lowercase s, which you'll be doing in your assignment for today, this is how you want to do it. You want to say, when I'm using this least squares regression line, and you talk about what your explanatory variable is and what your response variable is, there and there where the blanks are, then you would say we're typically off by s units. So you calculate s, or you can get s from your calculator, and then you include that here along with your units that you're using, just as we said on the prior page. The other bit of information that we can use if the residual plot maybe isn't good enough for us to take a look at, or if lowercase s we're not sure about, the other thing we can use is something called the coefficient of determination. This is another thing that describes for us how well the least squares regression line predicts our values of our response variable, which again is our whole reason why we're here in chapter 3. We're trying to come up with ways to predict the response variable. So as you can see here, r squared is 1 minus the residuals divided by y sub I minus y bar. So these residuals up here are your residuals that you're accustomed to, where you're comparing up in the numerator here your y values from your data points to your y values predicted by your line, and then in the denominator you're comparing your y values and your data points to the mean of your y values. So the blurb that's here I have again on the next page for you as well, but you have to be comfortable with explaining that this coefficient of determination, which is r squared, is referred to as the fraction of variation in the y values that's accounted for by the line of y on x. So we next want to maybe think about what kind of numbers do we want to see for this lowercase s that we talked about here, which talks about how far off we are, and this r squared, which talks about how much of the variation in those values are we picking up by our line. They kind of go hand in hand. They're not complements of one another, but s and r squared are going to move in opposite directions. So in other words, if you have a very small lowercase s, you're going to have a larger r squared, which is really what we're looking for. If you think about lowercase s on this prior page, you really want that value to be small. You don't want to be off by a lot, right? And then here for r squared, you want to be able to describe much of the variation in the y values that's happening by your line that you've created. Otherwise, maybe that line wasn't the best choice for you to model your data. So if we go back to that truck example that we did on the very first day of 3.2, we calculated a little r of 0.815, which was our correlation. We had talked about that early on. If you square little r, that is r squared, which is this coefficient of determination on the prior page, which is right here, this r squared. So here we have an r squared of 664. And this is just reminding you that you can find those on your graphing calculator. This is yet another sentence that you need to memorize and make sure that you can create, which talks about what r squared is describing. So here we would fill in for the truck example this 0.664. So in the truck example, 66.4% of the variation in our y variable, which for us was price, was accounted for by the linear model that we built that was relating price to miles driven. So again, you really want that value of s to be small. You don't want to have a lot of prediction error. You want r squared to be high. We would love for it to be 100%. We would love for our model to be picking up 100% of the variation in y that's accounted for by the line. This is part of the next lesson, so we don't need that. So that is the end of what I wanted to talk to you about today. I know it's just a short video. This goes along with homework 5 because homework 5 deals with you practicing describing lowercase s and r squared. So once you've watched this video, you should be able to take a look at homework 5 as well. And then tomorrow in class, we'll finish up with one more way for us to calculate a least squares regression line using some computer output and the formula sheet. And then Friday, we're going to do the Frappy. So the test won't be until Monday. So I hope you guys have a good day, and I will see some of you in class on Thursday and some of you via the computer. And please let me know if you have any questions or concerns. Thanks. Have a good day.